Righto guys, on this boiler we have what's called the throat plate. So I've got a couple of things to do on this. First one is the bore's a little tight for the boiler barrel, so I need to give that a little bit of a lick out. And over here on the two corners, I've got to machine these pads back and then drill and tap. I've got some holes that I need to drill and tap into these. And these stay holes, I need to open those out just a touch as well to be able to stay, so the stays become a nice neat fit in there. But we'll just open up this bore very slightly first and we'll see how we go. Once again, very slow speeds. Alright, I'm hoping this is going to be the last cut. I think this is the fourth one we've done, fourth cut through. Alright, we've achieved what we wanted to achieve, and that is a fairly neat fit on the barrel. There we go. So this throat plate's got to go down about 4 millimeters. So I'm really happy with that, how that's turned out. There's a very neat fit on that that'll make it easy for Andy to get set up. Alright, we'll move on to doing these two pads next, and we'll open up the stay hole so that the stays fit a little bit better, a little bit snugger. Okay, next order of business, I've got the two pads on either side that I need to machine back. So they're 2 millimeters up off the face of this throat plate. So we'll give that a lick on both sides, get them down to thickness, and then we'll machine the profile up that needs to go under here. Then we'll drill and tap each of the holes. Right, so it's down to 2 mil thick. I'll pop on the other side off camera and I'll get that machined up, and then we'll start setting up for the profiling. Alright, we're just going to clean this pad up now on the two edges, on the X and Y sides. So the height's got to be 19.5 and the width has got to be 19.2, so we'll just give it a lick through. I've already zeroed it out onto the plate. Alright, that came up really nice. Alright, we'll set up, we'll do the other side off camera, and we'll look at trying to profile a bit of a radius in there. Alright guys, the drawing calls for a 2 mil radius, so we're just going to try and put that profile in with this little cutter. Just going to take it very, very easy and see how we go. Alright, that came up really nice. Alright, we'll just do a little profile down the other side. Alright, that's come up really, really neat. Alright, I'll do the other one off camera and we'll get set up for our drilling and our tapping. Alright guys, I've got to put a bit of a radius on this pad just around here. I've marked it out. I've done a few different radiuses in there to see which looks best, and I'm just going to pick this one here. So I've marked it out on both sides, and all I'm going to do is I'm going to bring the end mill in and just peck at it. And I'll come in with my radius tool and once again just peck at it. I'll probably get it 90% there, and then we'll do a 10% hand finish on that to get that blended out. So I won't show you that, it's going to be pretty boring, and it's just going to take a bit of patience and a bit of time. Alright, we'll bring you back with the result. Alright guys, so those radiuses have come up really nice. And it's these fine little details that really bring a fine scale model to life. It gives it those nice lines that really pretty look. So I'm really happy with that. Alright, we'll get set up to do the drilling and tapping next. And then we can take this off, and before we do, I do need to bore out the stay holes a little bit. The laser's cut on a slight angle so the stays don't quite go in, so I'll just give them a lick with a boring bar just to open them up. But we'll get these holes drilled and tapped and ready. Alright, we need to put a couple of tapped holes into the corners of the throat plate for washout plugs. However, this one here is going to be a 3832 ME, and this one's going to be a 1/4 inch BSP, so this will have a 1/4 inch BSP plug in it. This will allow a second point to be able to fill under the code, to be able to fill the boiler if required, hence the 32 ME, but it also doubles up as a washout plug. You can take that fitting out and still wash out, but it's a second point to be able to fill from. Alright, let's do my next favouriteest thing with this stuff, and that is let's try and drill and tap some holes. Alright, the tapping size for the 38 ME is 8.5 millimeters. Now I've already done a couple of these already. I'm going to try and show you. You can see that land there, how that is built up. And as I mentioned on my previous videos, that this stuff is very gummy when it's soft, and it does build up on the edge of the tools, particularly the taps. And I think if you're going to break these, it's on the backward stroke. But you can sort of see, hopefully you can see how gummy that is and how that build up is on that tip. Alright, I'll go and give this a sharpen up, and we'll get into this one. Alright, while we're set up here, we'll get that hole tapped as well. And I've got my spring-loaded centre in here to keep that position dead centre so that this tap doesn't wander off. So here we go with this, with the camera in the way. We'll just take it very easy. It's very important you get this hole cut without dwelling. As soon as you create that hard spot with taps, particularly the smaller taps, you're going to make life very hard for yourself. And just on the coolants, I've used the Rapid Tap, the Tap Magic. I've tried the Trefoil X, but this Roll Coal heavy duty lubrication oil, cutting oil, seems to be the best. Used to be a product out in the market called Chesterton. It was a clear liquid, and you can make a dog's tooth cutter a thread. It was so good. You could have the bluntest tap in there, but you'd end up with the most perfect thread on it, and had a bit of a strange smell to it, but they took it off the market because it was carcinogenic. But honestly, it was the best tapping fluid I have ever used. It was brilliant. Alright, we're getting through this alright. You can hear that cutting really nicely. As I said, the key is not to let this stuff harden. Alright, we'll set up and drill the 1/4 BSP thread on the other side now. Alright guys, I'm going to be tapping this for 1/4 BSP T. pretty standard pipe tapered. That's to fit this little pressure plug. We call these a pressure plug. They've got a hex drive, or same as the Allen key type drives. And the idea of these pressure plugs is they will sit flush with the plate. They won't be sticking out like you get with the big ugly hexagon, particularly on fine scale models. These look quite nice. All right, let's get it tapping. And I'll be taking this in and out and just trying this as I go until I get that nice and flush. All right. I'm going to just move the camera out of the way, finish these off, and we'll come back when we've got this tapped to size. All right, I think we've got a good result. And that's just starting to come on tight now. We're maybe about 1.5 mil up above the surface there. So we won't push that all the way. That will come up flush when it is all the way home, but there's a bit of tension on that now, so I'm not going to tap that out any further. We'll leave it at that. Very happy how that's come up. Alright, last job we've got to do on this throat plate is I've just got to rebore these two stay holes so that the stays will fit through. Alright, we'll get set up and do that, and then this one's done, ready for Andy to set up for welding. Always add a little chamfer to your holes when they're completed. Just finishes them off nice, and it makes it easy to get that fastener, or that in this particular case the plug, started. All right, let's get it set for some boring. All right, we're getting set up for boring now. This is a dummy pin that I made up before I made up the stays, just to trial the processes out and the threading. So that's what I use for my fit. So as you can see, it gets caught up in there. So when they've laser cut this out, this has cut with a fair old taper on it. So we need to take that taper out to get that stay to fit nicely. All right, it's on the money. I'm happy with that. Right, we'll move across and we'll do the last one, and that's the throat plate finished. Alright, so that's the work completed on the throat plate. I'm just going to spend a bit of time with some needle files just to tidy up these radiuses and these corners and get them to blend out quite nicely. But other than that, that's all ready for weld up. Alright guys, we'll see you soon. Right guys, we're back with this little Ransomes, Sims and Jefferies portable steam engine, and we're going to be doing some work on the back head, and this is where all the action happens. This is where you have your fire hole door to feed that firebox. You've got the regulator, you've got your gauges, various steam cocks that happen on the back head. So 90% of the work or the operation of a steam engine happens in this area. So we've got to start looking at putting some of the furniture into place, or at least some of the fasteners, drilled and tapped holes to fasten those that furniture into place. And it's important we try and get things looking right by eye. We've got some drawings here. That my brother Andy's done, showing all the drilled and tapped positions for a lot of the holes. Later on down the track we need to do some holes to be able to put in some blind rivets to give the riveting effect for the back head as well. That's a little bit further down the track. At this stage we're just going to concentrate on doing these tapped holes. The first that I need to do is for the hinge for the fire hole door, and the archway across the top, and the latch. And what I've done quickly is I'm going to drill single holes for the positions of the various items, and I've made up some little pins that will go into those tapped holes or drilled holes ready for tapping, with a little protrusion on them to fit into the holes, which are 3 mil. So we've got the one done for the fire hole door. and that's going to get positioned up. Once that's in position, I can then use that hole as a reference to be able to spot through and get that positioned up perfectly. Now what I've done here is I've used my square, my engineer's tri-square. We've got it squared up across here, which is dead smack parallel with the edge of the firebox. Across the top, it is absolutely spot on. But we have an issue across the bottom here. We're at about 1 millimetre up at that end there. So I'm going to aim to get these two 90 degrees and parallel as a starting point. And when this is sitting up, you're not really going to pick that out. It's not going to be well defined, be able to see that is a little bit out. What I've also done is on the fire hole door, I've marked a number of reference lines so that I can get this door dead smack central to the actual fire hole itself. We also have an archway that needs to go on top here, and it sits up above there. And once again, I've done some reference line work, and I've actually moved this up a couple of mil. When I laid this out in the drawing, it lays out around about here, and as you can see, it's almost touching. So we're going to move that up a couple of mil and just reposition that. And once again, this is a thing that's done by eye. We need to use our eyes to look at what's going to give us the most pleasing look when we're putting these small scale units together. And then we've got the latch that needs to go on here as well, and that'll sit there as well. And once again, we'll position that, and I'll use my little pins. I'll drill the first hole, put the pin in, hold it in place with an engineer's clamp, and then we can use the other hole as a reference to spot through and get things right. Alright, just a quick little thing on squares. This is what's called a grade B square, or it's a AAB. It's to a British standard, 939, and we still refer to a lot of British standards in our Australian standards, particularly around measurements. And if you look up the specs on a grade B, this one here is a Toledo. The maximum amount of tolerance for the blade to the stock is 16 microns, and that refers back to around about 6/10 of 1 thou. So still extremely accurate. I use this particular square on working a lot of these type fabrication things. I do have my Precision AAA that I only use for machine work, but this grade B, as I said, 16 microns, is more than comfortable with doing the layouts for this type of work. All right, well, I'll get this marked up, positioned up. We'll get this clamped into place. We'll get the second hole spotted. Then we'll move on to the archway. Then we'll move on to the latch. All right, guys. We'll see you in a tick. Alright, so I've just spotted through with a 3mm drill to make sure that we get this perfectly in line between the two pins. I'll take that out and I'll open that up to the tapping size for the 5mm. I've just measured this with my calipers, and yes, we do have a 1mm difference from edge to edge. I think this side's measuring up at 63.5, we're down to 62.5. So just having a look at it, it's possibly in the pattern, the original pattern that was made to do this, that's caused that issue. Looks like possibly the hinges are silver soldered in as well. A little bit hard to tell, they may have been. I can see some silver solder that's in there. Maybe that was put in to repair some little flaws in it, possibly. But this is an ideal candidate for doing a casting in one piece. So the actual plaque inside the rim and the hinges all in one with a small core printout to the side. So if you're looking at doing these sorts of things, just have a look at how you're going to set up your patterns, because basically that becomes the foundation. There's often not far you can move once that pattern has been made, and if it's incorrect, you'll end up with an incorrect casting. Then you're chasing your tail the whole time to try and get things proportionate and squared up. All right, we'll get this off, and as I said, we'll drill through with our tapping size. Alright guys, spent a fair bit of time getting this latch lined up to try and keep it as parallel as we can against that face there, and as parallel as we can to the face of the fire hole door latch section. So I'm very happy with where that's at the moment. So I've zeroed everything out. I'll take this out, take it away, and then we'll send a drill and drill through. We'll put a pin in and clamp it up and do the same thing again. So this part of the fire door is dead parallel with the edge, so that looks quite nice. I think that section here we're out of parallel quite a bit. When we're looking down at the boiler, you're not going to pick that up at all. So this sort of stuff here that's in relationship to each other, you certainly will. So we need to try and take some extra time to get that as close as we possibly can. We've got about a mil gap in between the latch and the door itself. Alright, I'll get this apart and we'll pull this off. Just before I do go, I've got a little set of engineers clamps here, and I got this off a very, very old friend who's passed away a number of years ago now, Dan O'Toole, and I spoke to his son when they were sort of packing up all his workshop, and I asked if there's anything that I could have that he might have used fairly regularly, and this was certainly one of the things he'd certainly used between himself and his father Vin. They were wonderful old model engineers in the Geelong area, which is where I live, and they had a beautiful loco track running around their house and their garden. It was magnificent, and used to have a lot of the Geelong conventions they used to host at their home, and yeah, wonderful memories of old Dan. All right, we'll get this apart and we'll get this on the go. Alright, job's done. So I've got 2 pins in this now, and you can sort of see we've gapped that up very, very nicely. So that's come up a treat. Alright, we'll move on to the drilled and tapped holes. I won't take you through it, I'll just show you the finished result when we're done. And I'll show you the idea that I've got for fitting the studs into here. So obviously we've gone oversized on the holes so that we can get a better chance with the tap without breaking. And I'll show you my idea that I've got for filling those up so we can get some nice little BA studs or bolts into there. Alright guys, so we've got these M5 tapped holes for holding the fire hole door and the components for the fire hole door. As I said, trying to drill and tap small holes into this sort of material is an absolute nightmare. So we've elected to go for a larger size hole. We've made sure that the M5 holes that go into this are within the shadow of the componentry, so you're not going to actually see that hole in any way. And the plan is that a little bit of M5 all thread, no that's not all thread, but that's a solid cap screw, but the idea would be was you'd get yourself a bit of M5 all thread, set it up in the lathe, drill and tap through to the size that you want for the fastener to hold that component down, cut it off and leave it just a little bit longer, and screw that into your M5 hole. And add some of the high temp Loctites. Now the high temp Loctite will go up over 300 degrees C, the stuff that you can purchase. But leave it a little bit longer with a pair of vice grips. Really wrench that in really hard to get that bottom straight down. Let the Loctite go off, then cut it back, and then just with the flapper wheel, just very gently grind it back flush. Then you've got the hole that you need, the tapped size hole you need within that threaded plug. As I said, makes it so much easier if you can use the bigger tap rather than a smaller tap, because I can guarantee you with this stuff it's going to break. Alright guys, so that's the plan, and that's why we've gone for the larger tapped holes. Alright guys, we'll catch you in a tick. Alright guys, we've finished drilling and tapping all the holes for the boiler furniture, and obviously around here for the fire hole door and latch and arch that's got to go on there. We've got some 1/4 BSPT holes tapped in the corners there for drains, and we've got a 3/8 32 MA in there. So I can tell you, doing these ones caused a few moments of angst, particularly on reversing back the tap to break the chip. This stuff is just like Gumby Bear stuff. It's shocking. It really gums up on the cutting edges and trying to back it off. So it was just little inches, little steps by little steps to work it through, and we got there. So I'm really happy with that. Everything else went through fairly easily. So the next thing I've got to do is a range of holes to mimic some rivets that are going to be put into place here, and I'll just show you those. Alright, so hopefully you guys can see that. You can see a whole range of rivets on that back edge, so we need to mimic that. So I have a huge amount of 3mm holes that I need to drill through, and I've got all the stud layouts here to fit these into place. And these are going to be Loctited in with a very high temperature Loctite. I think it'll take up to over 300 degrees C, this particular Loctite that's going to be used for this. So they're not going to move once they're in place, so it'll be good. But yeah, that's going to be a bit challenge, drilling those 37 holes to suit these rivet heads. Alright, that'll be the next setup guys, and we'll see you then. Okay, see you soon. Right guys, we've got to start these rivet holes now. Something I've been dreading to start, but it's got to be done. I'm going to break this up into two parts. I'm going to be doing this top section of the holes first, and then I'll follow that up with the bottom section. And it calls up a rivet that needs to fit in there, which is this one here, which measures up at 3.1 millimeters, so 4 or 5 thou over 3 mil. What I plan on doing, because this material is so horrible to drill with, I did try using a 3mm cobalt drill, and over the length of it you can really see it torquing, or really feel it torquing. So if I do too many of these, I think I'm going to snap it. So what I'm going to do is go through with a center drill. That center drill measures around about 2.8 across the cutting edges. So I'm going to do the first row, as I mentioned, the first bunch of rivet holes. Then I'm going to swap over, I'm going to put in a 3mm end mill, and we'll finish them out with that. So it's going to leave it, you know, a little bit undersized, which is fine. They've got to be a tap-in fit. So the customer may have to machine the shanks on this very, very slightly, but I've got no other real way of doing that. The advantage of using the center drill, I'm going to go down 3mm. The hole asks for 2.5, but I'm going to go down 3mm so that I'm not too sure whether this is a center drilling end mill, but it just means we can leave a pip on the bottom, and we're not going to run that right down and break it. So that's the plan. We'll go through first with the center drill, and then we'll follow it up with the end mill. Now what I've done is I've set my stop up on the Bridgeport head, so I come down at a precise amount each one, and then we'll do the same with the end mill. And then we're going to use the DRO to map these out. So when we put this in, we should be able to match it up perfectly again. Anyway, that's the plan. and we'll see how it goes. All right, that's everything run through with the center drill. I'll set up that little end mill, and yeah, we'll hold our breath and we'll see how we go cutting those out to size. All right, here we go with the first one. Fingers crossed. .5, right in the money. Only thing with working with this Bridgeport, it's not a very sensitive head. You haven't got a very good feel on how this is. You can't feel the cut and you can't feel the resistance. So it's just a matter of taking your time. All right, we'll work through these now and hopefully have a result. Righto, that's all that top row now completed and completed well. I'm very happy with how that's turned out. You can feel the pin doesn't quite go in, so it may need to be linished a little bit just to get those little bits in there, get them peened out. All right, I'll set up now and we'll do the bottom half. There's a little bit more of a zigzag in these. What's made this a little bit harder too is the customer has wanted odd bod dimensions from the centre out on each set, so you've really had to concentrate and focus to make sure we hit those marks. All right, we'll get ready to set up with the centre drill and we'll start doing the lower half. All right, guys, well, that's the back head completed. We've finished all of our drilling and tapping for the fire hole door, latch assembly. We didn't break a tap, which was a bonus. We've completed the taps for the blowdown points on the corners and tapping for the water gauge and some of the cocks, some of that boiler furniture that goes on. And we've also done all the blind rivet holes as well, ready for the customer to put those rivets in. So this and the boiler fabrication go up to the boiler inspector in New South Wales without this attached, so that he can look inside. Once he's approved everything, it comes back to Andy. Then he welds the back head on, and then I've got a fair bit more machining to be done on the boiler itself once the weldment's completed. So a little bit more to go on this. So we'll keep you updated on how that all progresses. All right, guys, we'll see you soon.